NASA has just successfully landed its most ambitious ever mission to Mars, and its mission is to search for ancient life that may have existed billions of years ago.
NASA recently released a series of alarming images, including one dubbed Mars Henge, depicting rock formations on the Martian surface resembling ancient stone circles found on Earth. These images have sparked speculation about the existence of ancient Martian civilizations. Meanwhile, astronauts aboard the International Space Station are confronted daily with the stark transition from day to night, serving as a powerful reminder of their isolation in space. Could these images provide evidence of extraterrestrial life? Join us as we explore the reveal these images and the possibility of potential contact with alien civilizations. The earthly ties of distant stars. Another fascinating view comes from the International Space Station. From up there, the Earth can be seen uniquely, showing the quick transition between day and night due to the station's fast orbit around Earth. This fast-paced view is beautiful, but also highlights the unusual and somewhat artificial living conditions astronauts experience. Life up there is very different from what we see in movies, with strict schedules and life under constant monitoring. Such depictions often tap into our fascination with the unknown, enticing us with the possibility of life elsewhere or hidden dangers lurking in space. They paint a picture that draws us in, playing on our fears and curiosities about what exists beyond our planet. While these stories are engaging, they frequently move beyond the bounds of confirmed knowledge and enter the realm of speculation. Images from space can indeed be unsettling or make us wonder about the universe. They turn into a backdrop for our guesses about extraterrestrial existence and the broader unknowns of space. As we continue to explore and send technology into distant parts of space, we are likely to see more such intriguing images. Each photo that comes back from space gives us a bit more information about the universe, although we should remember to view these with a critical eye. While it's exciting to think about the possibilities of what each shadow or odd form might mean, these are often just small parts of a much bigger picture that we are still trying to understand. The reality is that while the universe is immense and filled with incredible sights, not every peculiar detail we spot is a sign of something extraordinary. These are often just bits and pieces of the larger scene of space, which we are only beginning to understand. So, while we should remain curious and eager to learn more, it's also important to stay grounded in what we actually know. The International Space Station completes a full circle around Earth every 90 minutes, traveling at a fast pace of 8 kilometers or 5 miles per second. This speed lets those on board see 16 sunrises and sunsets each day. Yet when darkness falls, the atmosphere inside the ISS changes dramatically. The minimal lighting hardly pushes back the engulfing darkness, making it feel like a perfect setting for a spooky movie, intensifying feelings of isolation and vulnerability for its occupants. On Mars, the Curiosity rover continues to explore and send back data that fuels debates back on Earth. Last year, it captured an image that particularly caught people's attention. It showed what looked like a doorway carved into a Martian rock face. This sparked discussions about whether it could be a sign of past intelligent life. However, it's more likely a result of natural erosion. The formation's sharp right angles and what looks like an overhang might suggest careful crafting, but nature often creates patterns that can deceive the eye, making natural formations appear man-made. Over in space, the James Webb Space Telescope has been busy capturing images that could be seen as cosmic artwork. These photos of celestial events, which could whimsically be called a galactic phoenix, display the beautiful complexity of space. Such images are breathtaking, but can lead people to interpret them in imaginative ways, thinking they see more than is actually there in these vast cosmic clouds. Both scenarios, from the dimly lit corridors of the ISS to the distant Martian landscape and the deep views captured by the James Webb, show how our perception is influenced by the context in which we see things. Humans are quick to fill in the blanks and eager to see patterns, sometimes imagining doors where there are only rocks and seeing mythical birds in clusters of stars and gas. This readiness to weave stories from the bits and pieces we observe is not just a sign of our creativity. It underscores our deep-seated desire to make sense of the surrounding spaces, regardless of how far or shadowy they might be. This human tendency to interpret and reimagine the information from space can lead to a sense of wonder, but also to skepticism. As we peer into the depths of space or scrutinize the surfaces of other planets, we are constantly reminded of the limits of our knowledge. Each new image or piece of data invites us to question what we think we understand about the universe. Whether it's interpreting the eerie glow in the ISS, speculating about rock formations on Mars, or marveling at the images sent back by telescopes. Telescopes like the James Webb Space Telescope have given us very clear pictures of space, showing details of stars and galaxies like we've never seen before. For example, the JWST recently captured images of the Phantom Galaxy NGC 628, which is 32 million light-years away. In these images, the galaxy appears bright and vibrant against the dark backdrop of space. These photos, taken with JWST's special cameras that see heat, not only show us what the galaxy looks like, but they also seem designed to capture our attention and make us wonder about the universe. Let's explore what it's really like to be an astronaut beyond the glamour, the unseen dangers of space exploration. Closer to Earth, the life of an astronaut, while often seen as exciting and unique, comes with significant risks. The famous 1980s image of astronaut Bruce McCandless flying freely in space, far from any spaceship and only aided by a jetpack, highlights the dangers astronauts face. He was completely untethered, floating in space where a small error could have been disastrous. While impressive, this image shows how dangerous space travel can be. The risks involved in being an astronaut are real and significant. The appeal of moving weightlessly through space is strong, but it's important to remember that space is a very harsh place. Images like that of McCandless might make the job look thrilling and heroic, but they also tend to hide the serious and often not so exciting scientific work that astronauts and scientists do. Space agencies and the media often present space exploration as an exciting adventure. They show us beautiful pictures and thrilling stories, but they don't always talk about how complicated and dangerous it is to work in space. It's easy to get caught up in the stunning visuals and forget about the real challenges that come with exploring space. The focus tends to be more on making space look appealing rather than on the detailed, scientific efforts involved. This tendency to emphasize the dramatic aspects of space may influence how people see space exploration. They might start to think of it more as a series of spectacular adventures rather than a complex field requiring careful and meticulous scientific study. As we enjoy these incredible images from telescopes, we should also try to understand the full story they tell, including the challenges and risks that scientists and astronauts take to bring us these views of our universe. Since its launch in 2011 and landing on Mars in late 2012, NASA's Curiosity rover has been diligently making its way across the Martian landscape, gathering a variety of data. Over the past decade, it has sent numerous findings to Earth, including evidence that liquid water once flowed on Mars. However, along with these important scientific discoveries, there have been other observations that are more difficult to explain. For example, a few years ago, while Curiosity was monitoring the levels of methane in the atmosphere, its cameras detected a bright flash of light in the distance. This unexpected light appeared on the horizon and was initially thought to be a simple reflection of sunlight off a rocky surface. Some might consider this explanation a bit too simplistic, almost as if brushing off something potentially more significant. Is it possible that we're too quick to dismiss these occurrences without a thorough investigation? Perhaps this could have been a chance to learn more about the Martian atmosphere or geological processes. Yet these types of data often end up being ignored or inadequately explored. Moreover, such instances highlight the challenges and limitations inherent in robotic exploration of space. In a place as unknown as Mars, every piece of data is crucial and merits detailed analysis, not just a cursory glance and a quick classification. This tendency to overlook anomalies might suggest a larger issue in space exploration. The excitement for groundbreaking discoveries might be overshadowing the importance of consistent, detailed study of less spectacular data. It's sensible to avoid jumping to wild conclusions, but it's equally important to stay thoroughly inquisitive. If we too quickly write off unusual data as mere quirks, we might miss out on findings that could reshape our understanding of Mars's environment. Continuing this reflection, the approach to such unexplained phenomena on Mars should perhaps be more reflective and cautious. If every anomaly is passed off as a trivial matter without substantial inquiry, significant discoveries might slip through our grasp. The scientific community might benefit from adopting a more rigorous approach to these lesser findings, treating them not as bothersome exceptions, but as potential keys to unlocking new knowledge about Mars. Critics often dismiss the unusually bright appearance and possibly artificial structure of the celestial object, suggesting these traits indicate something unusual about this tiny spot in space. However, this view may be missing at a deeper, more complex story about what these characteristics suggest about the universe and our understanding of it. The discussion becomes even more interesting when you consider that astronomers predict our Milky Way and its closest galactic neighbor, Andromeda, are on a path that will lead them to merge. This isn't just a simple meeting of galaxies, but a massive transformation of the galactic structure that could change the way we understand the cosmos. These cosmic events challenge the usual ways we think about the universe. They expand the boundaries of our galactic neighborhood and make us rethink our place in a universe that might be more dynamic and unpredictable than we previously thought. However, the way these events are often talked about leans more towards the dramatic rather than focusing on the scientific facts, which can alter how the public perceives these cosmic events. Moreover, the stories told about these observations and predictions typically don't fully explore what such cosmic collisions mean. While they are intriguing and capture our imagination, they also pose serious questions about the future of our galaxy, the destiny of many stars and planets within it, and the stability of space environments. These conversations should shift to focus more on the consequences and less on the spectacle, encouraging a deeper understanding and respect for the cosmic forces at play. Next, we dive into what happens when galaxies collide, a future of galactic convergence. As these two massive galaxies inch closer over billions of years, the eventual merging will be a spectacle in the night sky. It will also bring about significant changes in the gravitational forces that could affect every system within them. This event will likely lead to the creation of new star systems, the destruction of old ones, and may even alter the course of solar systems, including our own. Understanding these profound changes requires a shift from viewing these events as mere astronomical anomalies to recognizing them as natural and significant processes in the life cycle of galaxies. Such a perspective helps demystify the universe's workings and promotes a more informed and rational appreciation of the vast forces that govern our cosmic environment. The narrative around cosmic events must evolve, focusing on their long-term impact and the scientific principles underlying them, rather than merely presenting them as distant or inspiring phenomena. By doing so, we can foster a more scientifically literate society that appreciates the complexities and the majesty of the universe without resorting to sensationalism. While we often worry about the small problems of everyday life, the universe is quietly preparing for an enormous event, the merging of two galaxies. This might sound impressive, but it won't start for another 4 billion years, so there's no immediate concern. NASA, however, seems keen on giving us a preview of this distant cosmic event, perhaps to remind us just how small our concerns are in the grand scheme of things. Or maybe to show off their ability to predict such far-off phenomena. The merging of galaxies is a slow process, taking millions of years to complete. It involves the galaxies slowly coming together under the force of gravity to form one larger galaxy. It's a common enough occurrence in the universe, but it tends to be portrayed as a spectacular and rare event. So what does this mean for what we see in the night sky? NASA tells us that as these galaxies get closer, our view of the stars will change gradually. The familiar patterns of the stars, our constellations, will blend into new forms. However, this won't happen in our lifetime. In fact, it won't even happen in the next few thousand lifetimes. The first noticeable changes in the sky will be long after anyone alive today is gone. NASA's detailed previews of this event might seem a bit over the top. One could argue that they might be trying to distract us from more immediate concerns here on Earth by focusing our attention on a slow-moving celestial event. It's as if they're using the grandeur of the universe to shift our focus from the here and now to the vast, unfolding drama of space. The reality is that while the merging of two galaxies is an incredible event on a cosmic scale, it's so far removed from our daily lives and timeline that it hardly impacts us. Yet, we find ourselves drawn to these predictions, perhaps because they spark our curiosity and give us a broader perspective on our own lives, highlighting how short-lived and insignificant our problems can be in relation to the cosmos. Imagine driving out to a remote area far from city lights, a place famed for clear night skies, and looking up to see not just the familiar stars, but another galaxy inching closer to our own. This visual spectacle, while stunning, is also a stark reminder of how small and unimportant our place in the universe really is. As these two giant galaxies slowly collide and merge, it's like watching a cosmic dance of stars and planets, all pulled and pushed by invisible gravitational forces. After this grand cosmic event, Earth is likely to remain, though not without undergoing some upheaval. Our own solar system will be thrown into disarray, with planets and moons getting knocked around. This would be similar to balls scattering in a game of pool after a strong break shot. Eventually, though, our solar system will settle into a new position within this larger, newly formed galaxy. This dramatic merging of galaxies isn't just a rare cosmic performance, but also a vivid illustration of the universe's lack of concern for the daily goings-on of human life. It highlights the fact that the structures and systems we consider permanent are in fact quite vulnerable and temporary, subject to the vast and impersonal forces of nature. While astronomers and scientists might find this event exciting, as it offers a wealth of data and insights into the dynamics of galaxies, for the casual observer gazing up at the night sky, it brings a sense of our own fleeting existence. The spectacle serves to humble us, making us reflect on the grand scale of the universe and our minuscule part in it. Each star that shifts, every planet that finds a new orbital path tells us that change is constant, even in the seemingly unchangeable heavens. Thus, while the merging of galaxies is a scientific curiosity providing much material for academic study, for those standing under the vast, star-filled sky, it can also be a contemplative experience. It challenges us to think about where we stand in the broad expanse of space and time, reminding us that our stories, however significant they might seem to us, are just tiny notes in the grand symphony of the cosmos. Just 400 light-years away from our own planet, there's a carbon star named CDW Leonis that's slowly dying. This isn't a quick or dramatic event. Rather, it's a drawn-out process that will likely continue for several decades. While fascinating to some, the star's demise follows a predictable pattern that, despite its appearance of a spiderweb from afar, is quite mundane on the grand cosmic scale. Let's witness the slow fade of a dying star. Life, death, and decay in the cosmic arena. The slow decay of CDW Leonis is hardly unique or spectacular in astronomical terms. It's simply going through the stages that stars like it inevitably experience, gradually losing its mass and brightness as it inches towards its final phase. This gradual breakdown might catch the eye of astronomers and casual observers alike, yet its scientific importance is more or less routine. Observers of the star might indulge in a bit of irony. Here we have a star at the end of its life, acting out its last scenes in the universe. And yet, what it really illustrates is the routine nature of stellar evolution, nothing out of the ordinary. It's a process governed strictly by the laws of physics, lacking any surprising or unusual elements, performing exactly as expected within the universal laws. As CDW Leonis slowly unravels, spreading its material into space in what might be seen as a delicate cosmic dance, its actions might prompt some to reflect on larger, more philosophical thoughts. Perhaps watching a star fade away stirs thoughts about our own fleeting nature and the relentless tick of time. In this way, the star's long goodbye might resonate more deeply with us, serving as a stark reminder of our own mortality and the continual march of time that affects all things in the universe. Thus, as we continue to observe CDW Leonis stretch out its final years, we are reminded of the commonplace nature of such celestial events. Every observation, while scientifically valuable, also offers a quiet reflection on life's impermanence. In a universe filled with countless stars blinking out of existence, CDW Leonis is just one among many. The slow departure from the cosmic stage is a quiet echo in the vast emptiness of space, watched by humans seeking connection and context in the predictable patterns of the stars. As stars run out of fuel, they begin to cast off their outer layers into the endless space around them. This process sends out tangled webs of orange and red clouds filled with carbon dust and soot. These remnants, products of a star's final breaths, are stark evidence of decay rather than creation. Carbon is the basic element that all life on Earth relies on, and these carbon-rich clouds could hint at the possibility of life on other planets. However, many scientists argue that life elsewhere might use this same building block, which might be a bit short-sighted. It seems like an easy guess, given our own experiences, but it may not account for the myriad of other chemical possibilities that the universe could offer. The spectacle of a dying star scattering its pieces across the void paints a vivid picture of the universe's indifference to the dramas of life and death. To assume that distant life forms must be carbon-based like us might overlook countless other life-supporting scenarios that haven't been imagined yet. The death throes of these stars, sending their essence into the cosmos, might seem to hold the promise of new life elsewhere. However, this is just as likely a signal of an end as much as a beginning. This cosmic process underscores a broader truth about the universe. It is vast, it is cold, and whether it fosters life or ends it is often a matter of chance and circumstance, far removed from the sentimental hopes of human observers. The potential for life to arise in the scattered dust of dead stars might seem poetic, but it is also a reminder of the immense scales and forces at play, which are neither kind nor hostile, merely indifferent. Could the same cosmic processes that light up the sky with stars also be the reason our solar system is rich with the carbon that allowed life to begin on Earth? It's an intriguing idea, but we should be cautious about assuming that what happened here is something special that will happen elsewhere. These stars, which burn brightly and eventually explode, spread their carbon-filled leftovers far across the galaxy. It's possible that this material could one day gather together to form another place where life might start, far away from the warmth of our own sun. But while we like to think about these possibilities, we also keep getting ongoing signals from space that we can't immediately explain. Rather than jumping to the exciting conclusion that these signals are from other civilizations, a more critical view might suggest we're just picking up the normal sounds of a busy universe. These signals might just be the ordinary noise of space, not hints of distant life. When we think about cosmic signals and the chances of life starting elsewhere, we need to mix our natural curiosity with a healthy dose of doubt. The universe doesn't exist to fulfill our stories of wonder and beginnings. It follows its own rules, which often don't fit neatly into our stories or our hopes about where life might next take root. So as we continue to receive these unexplained signals and think about the role of stars in bringing life-giving elements like carbon to planets, we should remember that the universe is vast and complex. Every flicker and whisper from the cosmos doesn't necessarily point to new life. More often, they might just be the echoes of the ordinary workings of the universe, a reminder of its grand scale and our place within it. This perspective keeps us humble and reminds us to stay grounded as we explore and try to understand the vastness of space around us. Each discovery and each unanswered question leads us further into the depths of our cosmic neighborhood, always with a blend of hope and caution, eager to learn more, yet mindful that not every puzzle will have a solution that leads to new life. Over the last 10 years, radio telescopes all over the world have detected a variety of signals coming from many parts of the galaxy. These signals were initially thought to come from usual cosmic events like exploding stars or black holes consuming matter. However, occasionally these signals don't behave as scientists expect, leaving them puzzled and unsure how to explain them using standard scientific theories. Are these signals from space signs of something more? The Skeptic's Guide to the Universe. The situation has caused some doubt among scientists. While it's exciting to think about discovering new phenomena or even making contact with alien life, the reality is that it's easy to misinterpret data. Many in the science community worry that excitement over finding something new can lead to seeing important discoveries where there are none. The romantic idea of discovering life beyond Earth can influence scientists to jump to conclusions. Many experts have noticed that some strange signals don't seem to match any known cosmic events, which has led to much discussion and debate. While some scientists speculate on what could be causing these unusual patterns, others criticize the tendency to immediately consider every strange signal noteworthy. They argue that odd results in the data are more likely caused by equipment issues or data interpretation mistakes than by genuine cosmic novelties. To complicate matters, the technology used to detect and analyze these signals is constantly evolving. New tools and techniques are developed regularly, which can change how signals are interpreted. However, with new technology comes new challenges. Calibration errors, technical glitches, and even simple human error can all lead to misinterpretations of what these signals might represent. Moreover, the debate over these signals extends beyond just scientific circles. The media often picks up on these discoveries and can sometimes misrepresent the level of excitement or certainty among scientists. This can lead to the public getting misleading information about the significance of these signals, further complicating the conversation. As each signal gets scrutinized and debated, scientists continue their work, improving their methods and hoping for clearer answers. Their goal is to peel back the layers of complexity and misunderstanding to uncover the true nature of these signals, whether they are just quirks of the universe or indeed indications of something more profound. Through careful study and continuous improvement in their techniques, scientists strive to ensure that their enthusiasm for discovery is matched by their commitment to rigorous scientific standards. The recent detection of a fast radio burst from the M81 galaxy, about 12 million light-years away, might mark it as the closest source of such phenomena we have found. It seems to have come from a dense cluster of stars within this galaxy. We're not sure what causes these powerful bursts, but they could involve dramatic events in space, like sudden star explosions or unusual cosmic interactions that we don't fully understand yet. Turning our attention to Earth, a photo taken by the Cassini spacecraft as it flew past Saturn shows Earth as just a tiny dot, a small blue marble floating in space. This image is a stark reminder of how tiny and insignificant our place is in the universe, which spans an incredible 94 billion light-years. Our own solar system barely measures over 1,000th of a light-year across. In a galaxy that stretches 100,000 light-years wide, it's like a drop of water in the vast ocean of the universe. Despite the overwhelming size of the universe and the mostly inhospitable conditions found throughout it, it's oddly convenient that Earth has just the right mix of elements, temperatures, and a protective atmosphere that allows life to flourish here. From a more skeptical point of view, it seems almost too convenient, like winning a cosmic lottery. Since there's no apparent reason our planet should be so well suited for life compared to countless others. However, this shouldn't make us feel important or central to the universe. Instead, it should remind us how fragile and unlikely our existence is. The universe at large is not designed for our comfort. Most of it is incredibly hostile to life. That we exist at all is more of an oddity, and our planet's ability to support life is more about luck than any destined purpose. As we continue to explore space and detect signals from distant phenomena like fast radio bursts, we learn more about the active and often violent universe beyond Earth. Each new finding highlights not how special we are, but how small and incidental our existence is in the vastness of space. These discoveries might help us understand more about the fundamental workings of the universe, perhaps teaching us about our own insignificance against the backdrop of such immense and indifferent cosmic forces. It's both a humbling and freeing realization. How strange and remarkable it is that we are here at all, able to contemplate the vast unknown from our delicate position, perched on the brink of cosmic vastness. Each new glimpse into the universe's scale and activity only emphasizes our tiny role in it, a fleeting presence in an enduring and relentless cosmic drama. In recognizing this, perhaps we can find a greater appreciation for the delicate balance that allows life on our small blue planet amidst the dark expanse of a mostly empty and unyielding universe. Does this realization make human effort seem trivial or more precious? Like, comment your thoughts below, and don't forget to subscribe for more explorations into the cosmos.